So imagine that in my hypothetical experiment I decided to throw a slip-and-slide party on the experimental half of the lawn and just put up a fence to isolate the unwatered half of the lawn. The experimental group of grass plants on the slip-and-slide half of my lawn would be getting plenty of water while the other half would stay dry. What's wrong with this experiment? Well, there are many problems. Water wouldn't be the only thing that happened to the experimental group. People would be running on it and churning up the dirt. A huge sheet of plastic would be covering a large section of the grass. The grass at the end of the slide would be getting a lot more water than at the top, and we wouldn't really be able to measure the difference. In other words, if we went to measure how the length of grass changed after watering, we wouldn't be sure whether the water, or the slide, or the people had caused the change in length. And also, while the water might be good for growth, the plastic and the people might not, so it would be hard for us to detect if the effect we were looking for was actually there. To avoid this, scientists standardize their experiments. That means that they treat both the experimental group and the control group identically in all ways except for the independent variable. Scientists sometimes describe this as controlling for confounding variables, or variables that interfere with your ability to measure the effects of your chosen independent variable. So the goal is to design an experiment to eliminate, or at least limit, the effects of as many confounding variables as possible. And the more thoroughly you do this, the more your experiment is actually testing your hypothesis, rather than testing the effect of some confounding variable. And when scientists evaluate each other's work, and even when you guys in class evaluate each other's work, you have to be on the constant lookout for confounding variables that might be leading people astray. So if Francesco Redi's dumb brother, Cianfresco Redi, decided to put a cap on top of the jar rather than gauze, and he said, "Look, there's no maggots that grow in here," you could say, there's a confounding variable. Maybe maggots would grow in there, but the fact that there's a top on your jar means that no oxygen can get in, and how could the maggots grow without that? Scientists are sometimes far along in their experiment before they discover that there's a confounding variable, and that's always frustrating. So one way to discover and control confounding variables from the start is to run a pilot study. So that's a mini version of your experiment. Just run just a small part of your experiment from the start to the finish before doing the whole thing. And then all along the way you can watch yourself and say, oh, was there a confounding variable here or there? And each place you can modify the design of your experiment, so then when you do the entire thing in full, you've already limited your confounding variables. So feel free to use a pilot study as a rough draft on your experiment and get all those confounding variables out of the way, so that you don't do something stupid like throw a slip-and-slide party on your lawn in order to test my watering grass hypothesis. One last strategy that scientists have to control for confounding variables is to repeat the experiment many times. What if the day before my lawn watering experiment there was a huge storm? Well, if all I did was measure the growth the next few days, then you might not be able to tell the difference between the half that I watered and the half that I didn't, because both sides of the lawn got plenty of water. That would be a confounding variable that creeped into my experiment. However, if I do this experiment over and over again, over a sustained period of time, and perhaps on many lawns, even when there is and when there isn't a storm, then I will control for those confounding variables, and I'll be able to present a stronger case in support or in refutation of my hypothesis. You can always be more confident of your results if you've gotten the same results multiple times. Thanks for listening to this video series on the scientific method. Ciao.